Howdy, students. So I thought I would share an example of how to solve a stoichiometry problem, specifically one of the toughest kind when you have to go from mass to mass. It could be mass to volume, mass to particles, but it's the same basic concept, and it is the most complicated type of stoichiometry problem that we're going to end up doing. So the example is, as you can read, given the following chemical reaction, calculate the mass of aluminum oxide produced when 804.7 grams of iron 3 oxide is reacted with excess aluminum. So we haven't talked about this much, but excess aluminum just means you're not going to have to worry about it. What you want to key in on is this 804.70 grams of iron 3 oxide and this, what you're calculating, the mass of aluminum oxide. And also take note of this reaction because it's going to come back. And this is why we practice naming. This is why we practice balancing, so you know how to do this. Where 2 aluminum plus 1 mole of Fe2O3, iron 3 oxide, reacts to form 1 mole of Al2O3 and 2 iron. This note is always on there, but good to know. So let me show you a tool that I'm going to give you called a mole island diagram. And it's just basically, you can use this tool to help you organize your stoichiometry, but this is how you'll do it. First, you figure out what your known is. So in this case, we were given a mass of iron 3 oxide. So I just note, I'm going to start right here, 804.70 grams Fe2O3. That's the mass. So first, I need to convert that into moles, which is part of why we practiced it. First, you need to know moles. Moles is how we compare different substances. So first convert it into mole. Then you're going to use the coefficients from the balanced chemical equation to convert it into moles of one substance into the other substance. So in this case, we had moles of Fe2O3, and it asked for moles of aluminum oxide. So we're going to go there. And then it wants to know what the mass of the aluminum oxide produced would be. So then we need to go from moles into mass, where you can see the question marks right there. If it had asked for volume of a gas, we would go here. If it had asked for the number of particles, how many atoms, how many molecules there are, how many formula units there are, you would go here. But you can use this general diagram for any of these type of problems. But let's show you how the actual calculations would work. So you have your given 804.70 grams Fe2O3. Oops. You have your given 804.70 grams of Fe2O3. And first you need to convert that into moles of Fe2O3. That's the first thing you should do. Always go into moles. So the molar mass of iron 3 oxide is 159.69 grams. I think that's 5.1. So you will convert into that. 1 mole Fe2O3 is 159.69 grams. Fe2O3, that's converting to moles. Okay, so that was the first step of this diagram. Now we are here. Now we need to convert from moles to moles. You look at your reaction. So in the reaction, we have 1 mole of Fe2O3 becomes 1 mole of Al2O3 in this reaction. So, and this always won't be the case, but in this case it is a 1-to-1 ratio. So 1 mole of Fe2O3, this goes down here, and 1 mole of Al2O3, this goes right here. Now, if it had asked to figure out the mass of iron produced, then you would have 2 moles of iron here instead of the 1 mole Al2O3, but you're lucky and you just have the 1 here. And then, if for the diagram, we're in moles. Now we want to go to mass. So we need to convert into mass. And these mass conversions are just like, 5-2 before we even went on e-learning. You just go 1 mole Al2O3, 1 mole, this is a mistake on my part. This should also say Al2O3, just like this. So we're over here, we're converting between iron 3 oxide. Here we're now converted into aluminum oxide. So this should also be Al2O3. That's my mistake. But it's 1 mole Al2O3, 1 mole Al2O3, and then the molar mass of Al2O3, just like if you were just given the number of moles, what the mass would be. So to review again, first, convert mass to moles, which we did in the first conversion factor, and then moles to moles, and then moles to mass, as we did in the third conversion factor. And then you're ready to solve the problem. Just like before, you multiply everything on top, you multiply everything on the bottom, and then you divide the top by the bottom because it's a fraction. As you can see, I've done that down at the bottom because really these are all going to cancel out. We've got, and this is a good way to check, grams of Fe2O3, moles of Fe2O3, moles of Al2O3. I know that this is wrong because I have moles of Al2O3 up here, and I should have moles of Al2O3 down here. And then we are left with something that doesn't cancel out, grams of Al2O3, which is what we're looking for. So we multiply everything on top, 804.7 times 1 times 1 times 101.96 grams. That comes to 82,055.3688. Too many significant or not significant figures, but I kept all my digits. And I divide by 159.69 times 1 times 1, or just 159.69. And that gets me 513.8 grams of Al2O3, which is our final answer. Again, this is just one specific example. If it had asked for just moles of Al2O3, we would have been able to stop right here. If it had asked for moles of or mass of iron, we would have iron right here. 2 moles of Fe, and then if it was a mass of iron, we would need 1 mole of iron, Fe here, and then the molar mass of iron right here. So the only real new thing is this guy in the middle, where we have to convert between substances. Otherwise, you have converted between moles and mass. You converted between moles and mass. You can convert between mass and volume and particles. But right here in the middle is the newest thing, which is the big takeaway you need to get from stoichiometry. So watch this. If you have any questions, email me. I hope that helps.